Hello everyone. Welcome to your physics class of class 6th. I hope you all will be fine. Students, in my previous video, I was explaining you lesson number 4, and in that video, I explained you functions of simple machine and also about mechanical advantage. So today in this video, we will continue that lesson. Okay, so let's begin our today's class. Today we will discuss about levers. A lever is a simple machine which we most commonly use in our daily life. A lever is a simple machine that we use in our daily life, and it is the simplest form. In its simplest form, a lever is a rod which can turn about a fixed point called the fulcrum. Means a lever is a simple machine which is in the form of a rod, which is a rod which can turn about a fixed point. So a lever is a rod which can turn about a fixed point called the fulcrum. Now, principle of lever. In this figure, you can see rod AB can turn about the fulcrum F. This F is a fulcrum of this rod, and this rod AB can turn about the fulcrum F. The rod AB thus behaves as a lever. The fulcrum of the lever is F, means this rod behaves as a lever, and this F is a fulcrum of this lever. Now, if an effort is E is applied at one point A on the lever and load is exerted at another point B, the distance FB of load from the fulcrum is called the load arm, and the distance FA of the effort from the fulcrum is called effort arm. Means suppose load is exerted here, and this is effort. So the distance between the fulcrum and the load is called load arm, and the distance between fulcrum and the effort, this is known as effort arm. Okay. So the point at which the load is exerted, that is a load arm, and the distance between the fulcrum and the effort is known as effort arm. When a lever is in balanced position, it is found that load into load arm is equals to effort into effort arm. I already explained you what is load and effort. Okay, so when this lever is in balanced position, that is in horizontal, load into load arm is equals to effort into effort arm. And you already know this. This I already explained you in the I explained to you in the last video that mechanical advantage of a lever is equals to load upon load arm. So here we can find out that load upon load upon effort is equals to effort arm upon load arm. Means load multiplied by load arm, load multiplied by load arm is equals to effort multiplied by effort arm. So here, from here we can find out that load, when we will find the value of load upon effort, means when this effort will move to this side. So load upon load effort is equals to effort arm upon load arm. Okay, so from here we can get this formula for mechanical advantage. Now thus the mechanical advantage of a lever is equal to the ratio of the effort arm to the load arm. Okay, so mechanical advantage of a lever is equal to the ratio of the effort arm to the load arm, and this is called the principle of lever. Okay, now if the load arm is greater than the effort arm, then mechanical advantage is less than 1. From this formula you can find out this, that when the load arm is greater than 1, then the value of mechanical advantage is less than 1. Means when the value of load arm is less than the value of effort arm, then in that case mechanical advantage of lever is less than 1. Now when the load arm is equal to this load arm, suppose effort arm is 5 and this load arm is also 5 meter. So when these two values are equal, we get the mechanical advantage 1. Now if the load arm is smaller than the effort arm, suppose the effort arm is 6 centimeter and the load arm is 2 centimeter. So in that case we get the mechanical advantage or 3 centimeter. We get the mechanical advantage greater than 1. Okay. So these are the three cases: when the load arm is greater than 1, effort arm, then the effort arm, then the mechanical advantage is less than 1. When the load arm is equals to effort arm, mechanical advantage is equals to 1. And when the if the load arm is smaller than the effort arm, in that case, mechanical advantage is greater than 1. Now, classes of lever. Levers are divided into 3 classes depending on the position of the fulcrum, effort and load. So first is class 1 lever, class 2 lever and class 3 lever. Class 1 lever. The lever in which the fulcrum is in between the load and the effort are called lever of class 1. Here you can see in this picture, fulcrum is in between the load and the effort. So this is lever of class 1. Generally, the effort arm of lever of class 1 is longer than the load arm. Therefore, the mechanical advantage of class 1 lever is greater than 1. Means in class 1 lever, effort arm is greater than load arm. Therefore, the mechanical advantage of class 1 lever is greater than 1. However, if the effort arm is equal to load arm, the mechanical advantage is equals to 1. But if the effort arm is shorter than the load arm, its mechanical advantage is less than 1. Thus, the mechanical advantage of lever of class 1 can be greater than 1, equals to 1 or less than 1. Okay. Some examples you can see here of class 1 lever. Seesaw and scissor, pliers, pair of plier, and beam balance, crowbar, claw hammer. These are the examples of class 1 lever. Here you can see the fulcrum is in between the load and the effort. Here also you can see the fulcrum is in between the load and the effort. Here also in this picture you can see a pair of pliers. This is attached from here. So fulcrum is here and here this is load and this is effort, means we apply the force here. So this is a effort and this is a load that this plier does work on this object. So this is a load. So this is, and in this case fulcrum is here, load and effort, and here also you can see this is a fulcrum, this is load and this is effort. So these are the examples of class 1 lever. Now class 2 lever. The levers in which the load is in between the fulcrum and the effort are called levers of class 2. Means the lever in which the fulcrum is at one end and the load is at to the closer to the fulcrum. Thus the effort arm is always longer than the load arm. Means here you can see in this picture that fulcrum is at one end and effort is at other end, and load is somewhere in between the fulcrum and the effort. Therefore, in this class 2 lever, effort arm is always longer than the load arm. Okay, hence the mechanical advantage of class 2 lever is always more than 1, because here effort arm is always greater than load arm. Therefore, the mechanical advantage of this lever is always more than 1. Some examples you can see here: wheelbarrow, nutcracker, paper cutter, mango cutter, lemon squeezer, bottle opener. These are the examples of class 2 lever. Here you can see in nutcracker, load is in between. Here is the fulcrum and here is the effort. In this mango cutter also you can see here it is joined from here. So this is a fulcrum, this is a load and this is a effort. Lemon squeezer, you can see fulcrum, this is load and effort. Therefore, effort arm is always greater than load arm in case of class 2 lever. Now class 3 lever. The lever in which the effort is in between the fulcrum and the load are called levers of class 3. Here you can see in this picture, this is fulcrum, here it is load and effort. Pair of tongs, these are the examples. A forearm holding a load, sugar tongs. In all these cases you can see fulcrum is at one end, load is at the other end, and effort is in between the fulcrum and the load. Here also load, this is effort and this is fulcrum. So effort is in between fulcrum and the load in class 3 levers. In class 3 lever, the fulcrum is at one end and the effort is close to the fulcrum. Thus, the effort arm is always shorter than load arm, and hence the mechanical advantage of class 3 lever is always less than 1. Examples I already explained to you. Now, do you know, in this you can see here, the mechanical advantage of lever can be increased by increasing the effort arm or reducing the load arm. And second, friction at the fulcrum reduces the mechanical advantage. Okay, now this is all for today. Now what you have to do, you have to read this lesson up to here. Okay, so it will be more clear to you, and further explanation of the lesson I will give you in the next video. Thank you.